Welcome to CodingKoans, where together we're going to explore the secrets of software, get better jobs, and change the world. My name is Carroll. I'm a software developer, and I'm going to be here as one of your explorers today, I guess. I'm going to use that word. I'm going to use the word explorers today, because why not? I have a guest, as per usual, but my guest is not anyone usual this time. Cyrus Vandrevela is a crafter at Eighthlight who has developed software in a variety of industries covering finance, insurance, travel, and education. He is passionate about sharing knowledge and has helped developers acquire new skills through training sessions, including object-oriented design and development, DevOps philosophies, and agile methodologies. And before joining Eighthlight, where he works, Cyrus earned his PhD in physics from Purdue University. Cyrus, welcome to the show. Go ahead and turn on your camera.
Hello there.
Hey, Cyrus, how you doing?
I'm well. How are you?
Oh, okay. I'm not allowed to leave my house right now.
Yeah, that's rough. One day.
One
One
day.
day.
Yeah. But I've got all the things a software engineer needs in their house, which is a computer. Any computer at all, really. So welcome to the show. Let me ask a little bit about, you work at Eighthlight. You've been working there how long?
A little over 3 years now.
3 years. Wow.
Yeah.
Okay, cool. And at Eighthlight, I know that I've seen you doing things with our apprenticeship program.
Yeah.
Yeah.
Yes.
So maybe I should, well, actually, do I want to ask that or do I want to ask the other thing? I'm going to start with physics. Why a
Okay.
degree in physics?
Because physics is awesome.
All right.
I honestly, I really, so when I was in high school, I knew that I wanted to do something with science or mathematics, but I couldn't decide what exactly that was. And so I started off in an engineering field,
Hmm.
and then I did some physics research at the undergrad level. I did some radio astronomy research, and I built or helped build a positron beam.
A
And
positron
then
beam.
yeah, like antimatter, like electron
Right.
and positrons. So I helped build, a beam at Marquette, and then I really liked it. So I said, okay, I'm going to go to graduate school, and I want to do some physics.
I love how you just casually throw out, oh yeah, it was just a positron beam, you know.
I mean,
Uh, all right. I happen to be a huge Star Trek nerd, so antimatter features a lot in Star Trek. I'm not sure how much you know about Star Trek, but
I dabble a little bit in Star Trek. Yeah.
yeah. And then, Data, who is the android on it, has a positronic brain,
Yes.
which I don't know what you get from that versus having an electronic brain, because, I mean, it's basically the same thing, just a lot more unstable.
Unfortunately, physics is my forte, not biology, so I couldn't tell you.
Yeah. So, but that's really cool that you got to work with antimatter. I am thrilled by that. Um, so, I don't have a degree in physics. In fact, my degree's in theater. I had a physics teacher in high school who was sort of a family friend because my parents were both teachers. So they knew all the other teachers around. Um, but I remember him saying to me, or saying to our class actually, that his class is just to show you around physics a little bit so that you understand what it is. He doesn't expect any of us to be physics majors. He even said like he's taught like 3,000 students and three of them were physicists, went on to become physicists, and he knew who they were the instant they walked into the class. Um, I'm not sure if that was your
It turns out it wasn't my experience because here I am in software development.
Right.
But when I was in grad school, um, what did they say? The statistic was like 1 in 7 physicists or science graduate majors actually does the science that they are originally studying for.
Hmm.
Everyone else goes off and does lots of random stuff. Software development is a really, really big one, and surprisingly, finance.
Yeah.
Physics and finance go hand in hand for whatever reason.
Huh.
Model building, I suppose.
Maybe so. Huh.
Yeah.
Yeah. Being a theater major, uh, we were basically told that math was wrong and that it wasn't for us. And because of that, anything that required math as a degree, such as physics, obviously you need math for that. Software, they would claim that you needed calculus in order to learn software at the university. You're
Well,
shaking your head at that.
I mean, I suppose that it is a lot of universities have the core requirement that you need to pass calculus to do the software engineering.
Yeah.
So I suppose by that technicality, that is true. But if you're actually talking about software engineering in the real world, with the exception of the like model building projects that I've taken on in my free time, I've never used calculus.
Never have you been paid to use calculus in software engineering, right?
Correct. That is correct.
What level of math have you? What's the highest level of math you've actually used in a paid software project?
Okay, so I need to be careful here because I'm going to say like this really fancy sounding math, but it's not. It's what like set theory and stuff, like
Okay.
basic logic, right? So like true false tables, if this is true and this is true together, they're both true.
Okay.
Basic arithmetic, uh, keeping track of loops and counts, stuff like that. So algebra level, I would say, is
Okay.
probably the big one. And that's if you're doing like normal everyday software engineering. Now, yeah, sure, there have been a couple of projects where I've been involved where I've had to build like cryptography, related things.
Okay. Yeah.
But so I'll say this: first rule of crypto is never roll your own crypto, right?
Right.
You never ever ever roll your own crypto. So I was not developing cryptographic algorithms. I was going through documentation saying like, oh, this is the algorithm I need to use for this particular use case, and then just going
So
into the Ruby standard library and going,
so
boop,
you didn't.
there it is.
Yeah. You didn't develop it. You didn't use the math to build it yourself. You just knew the names that you needed and what that meant as for how secure that crypto algorithm is, right?
Exactly, exactly.
So crypto, in case you don't know, audience, is means basically we're talking about security features in the software, meaning that someone can't log into your account and spend all your money for you, or any number of things like that. I also need to say this about math as well. One of the reasons why I didn't do the math was because in middle school I failed algebra twice. I failed it. I failed it once because the teacher would just refuse to explain to me what it could be used for. Like I just did not luck out on getting a good teacher. And then I failed her class, and then the next year they put me in her class again, same teacher. I failed it the second time, but she just passed me anyway to get rid of me. So you can imagine my confidence with math because of that. So yeah, my solution to software is like write very small things and keep the math very simple on each of those small things, and then I don't have to worry about trying to keep it all in my head.
Hmm. Hmm.
So yeah, but I think that's actually a pretty good strategy in general, though.
Oh yeah,
Yeah.
yeah. In fact, I would argue good math teachers will teach you that that's a good strategy in math. You take a big, complicated problem, you break it into a bunch of smaller, simpler problems that you can solve, and then you convert it back into the big complicated problem. That's
Oh,
how that's how a lot of physics and math works.
man, I think I could actually take those math courses now
Yeah,
after
I think
doing software. Crazy. You developed the part of the curriculum, I think, for Eighth Light's apprenticeship, right?
yeah, I helped develop some of the curriculum. Yeah, basically we kind of did a review of the topics being covered, prior to me joining the apprenticeship team,
Mm-hmm.
and then we kind of refined them and polished them and created a nice set of items that people are focusing on during the apprenticeship.
So what is the apprenticeship, and what does it mean for Eighth Light? What does that mean for developers who are maybe thinking about doing an apprenticeship program?
So when you say what is the apprenticeship, do you mean like how is it different than other training?
Yeah, is it an internship or what?
Okay, so the apprenticeship is really based off of the apprenticeship model, way back in the day. So back in the day, you had the master, say blacksmithing or whatever,
Right,
and that
about 1,000
master
years ago, let's say, right?
1,000 years ago, right? And they would do their craft, and they had to train the next generation of blacksmiths. So they would invite a few people in. Those people would work closely with the master for an extended time, learn the trade, and then the way it would go is they would then go out, train with other masters. We kind of romanticize that
Yeah, the
in a lot of movies
journeymanship.
and stuff. Yep, the journeymanship. And then eventually, hopefully, they settle down somewhere and they themselves become a master after much practice and time. So we try to do the same thing with software, where we basically pair up an incoming apprentice with the current crafter. That crafter does not have to be a master, self-proclaimed or otherwise, but someone to basically guide the apprentice through this curriculum. And they learn the basics. Over 6 months, usually, they learn the skills needed to be an effective software consultant.
And that's a paid position, right?
It's a paid position, correct?
Yeah. That's really interesting that, like, there are companies out there who, if they take an interest in you, will pay you to learn software because they really think that you're going to succeed.
Mhm.
It's yeah. Having gone through that apprenticeship program myself, having made you explain it to me when I very well know what that program is. Uh, yeah, it was great because you have somebody who's there, but you're left to your own devices. They give you just enough room to fail, and when you do, they turn it into learning opportunities, which is really cool. Yeah. Um,
Very rewarding, very challenging. Uh, there's one project that I personally really fondly remember is the HTTP server.
oh
For
yeah,
me, that was the point where I realized, like, oh, this isn't magic. I can actually do this, and then go from there.
yeah. It's not. Yeah, you're suddenly you know how to manipulate all the things at that point. It's
Right,
there's no layer where like you can't get past this. You have to have
right,
someone help you with this thing.
exactly.
Right. That's yeah. I see that as well. I didn't dare think about what it was that my mentor was asking me to do. I just tried to do it as best I could because if I started thinking about it, I was afraid I would just collapse under it. But yeah, and even now, I mean, it's been a couple of years, but I still don't see myself as very much different from how I was as an apprentice. Maybe a
Hmm.
little bit more experience, a better understanding of why we do things the way that we do. Um, but um, yeah, you never really grow out of that.
Yeah.
So you do DevOps otherwise, right?
Yeah, on my current client and a few previous clients, I've done my share of DevOps. So I will not say in any way that I'm a DevOps expert, but
Okay.
I have had to, you know, dive into it a few times.
Yeah. I think one of the themes here is that no one is really that much of an expert.
Yeah.
I mean, if you meet an expert, they're probably not really going to say, "I am an expert at this." They're probably going to say something more along the lines of like, "Yeah, I've done that a lot," or "I'm doing that right now."
Fair enough.
Yeah. But we're going to talk about some DevOps. We're going to play around with some DevOps stuff here. So, what is just to clarify? What is DevOps?
All right. So let me take a step back and kind of explain why the term came to be, right?
Cool.
So back in the day, we had dev and we had ops, right?
Okay.
So dev was the developers. They were making the cool features. They wanted the software to do new and exciting things, right?
Cool.
And so their goals were we want the app to do all sorts of great things for our clients.
Yeah.
And then you have the ops side, who was in charge of basically deploying the app and making sure it ran. And
Yes.
so their goal was like stability. We don't want change. We don't want things breaking. And so back like, 10, 15, 20 years ago, you can kind of tell they're kind of butting heads against each other, even though they both need each other, right? You need dev because you want your app to do stuff,
Right.
and you need ops because you need your app to actually run stably.
Right.
Um, and so after much fighting amongst dev and ops, there's this new idea of dev ops put together, where some of the responsibilities of the ops side of thing fall on dev and vice versa. And DevOps is a huge umbrella term, right? It involves things like good tests, a good pipeline, reliable builds, like all sorts of things. So it's very difficult to say like this one aspect of DevOps is DevOps, right? It rather
Right.
is this encompassing idea.
Cool. Okay. So, and you have something we're going to pair on today, right?
Yes.
It's
Yeah.
and we're going to be working on something called Ansible.
Right.
All right. So, what does Ansible do for us?
Okay. So we're going to, after my explanation of Dev and Ops, we're gonna sit squarely in the ops side of things for
Okay.
just a moment.
Cool.
So back in the day, I'll say it again. Back in the day, let's pretend you wanted to set up a whole bunch of servers that will run your app. So what you would literally do is you would SSH into each of the boxes one at a time, and you would install the necessary software and just go one by one. And this was not a great way to do things because number one,
No.
let's pretend you had hundreds or thousands of servers,
Yeah,
right?
Amazon.com, you can't do that on Amazon.com. There are millions of
Exactly.
people using it at any given moment, right?
Exactly. And more than that, there's a subtle thing that you don't really think about until it bites you in the butt. It's called drift, right? How can you guarantee that the stuff that you're installing on server number one is identical to the stuff on server number 50?
So, if it's the same software that you're installing on both of them, it should be the same, right?
You'd think theoretically it'd be the same, but I mean, we live unfortunately in the real world. So like hard drive on server one craps out on you, so
Oh.
you put in a new hard drive, and it just so happens the hard drive is just the next one up, right? Because you bought it later
Because, yeah, and they don't sell the other one anymore.
and they don't sell the other one anymore. Or maybe one server just happens to get a lot more load, and for whatever reason, parts are wearing out faster. Or maybe you're installing the operating system, and the operating systems are out of sync with each other because it literally takes you days to get through all the servers.
Right. Yeah. Okay. So,
So so people in the ops field realized that they needed a way to be able to do these changes to all of their servers in a controlled way where they could validate like if I do it to one, it's going to do it to all of them. right? And it's going to do it in a controlled, consistent sort of manner.
Okay, so it does it to all of them at once, basically.
Yeah, or very, very close to it, right?
Certainly a lot faster than if you were to go one by one.
Exactly, exactly.
Yeah. When I worked at Barnes and Noble, before I was a software engineer, I was in charge of their Nooks. And I would have to go through and manually update the software on each one of the demo devices.
Yeah.
And I'd just go one, do all the things on this one, then move on to the next one, do it all on that one. And so this thing, Ansible, is going to allow it so that all those things get updated at the same time, and you just write a little script that says what you want it to do, basically,
Exactly.
right?
Exactly.
Cool. All right, so I'm going to move our video a little bit to the side here so that we can sort of see what we're screen sharing.
Okay.
Let's play around with Ansible.
Sure, sure. So first and foremost, can you see my screen? Can you see Ansible demo?
Yep.
Terminal over here?
Mm-hmm. Yep, seeing it.
All right, perfect. So I've basically got us set up here just so we're not doing the Ansible install step. That's not so fun to watch.
Right, yeah.
But let me explain what this is over here first. So I don't know if people have used or heard of Vagrant and VirtualBox, but what this is it just allows me to set up a virtual machine. In this case, I'm choosing Bionic Ubuntu, right? And setting up a tiny little private network. And what that'll allow me to do is actually run Ansible against this little virtual machine. And that way I don't have to like spin up something off in AWS or DigitalOcean or whatever. We can do it locally. It's a little bit of a faster feedback loop. And this is just, oh, go on.
Okay, so a virtual machine, basically what we're going to do is instead of installing it on an actual server someplace in a data center, right, a physical device, we're going to create like a little software representation of that inside of our own PC.
Exactly.
So, and that gets into something I remember one of the DevOps people I know said to me once, is that anything that can be represented in hardware can be represented as software as well.
Yes. Yes.
So we're going to create a software version of the hardware that we would have installed to. And we're going to say that instead of doing Mac OS or Windows, we're going to install to Ubuntu, which is a type of Linux, right? And then we're going to involve our own private network. That's going to be something like a little, is it like an internal internet?
So to be honest, the private network part, you really don't have to worry about all too much.
Okay.
All it is basically if I want to access this box, I can ping it at 172.30.15.
Okay.
Right. And actually that kind of jumps into what I've got over here.
And ping it at 172.30.15, that means that if you were to type that into your browser, you would actually your browser would go to that place, right?
Yeah.
Okay, so we're going to use Vagrant to set that up for us.
And actually, I don't know if this is going to work. Let's Vagrant might stop me from doing this, but let's find out.
And the rest of this provision thing, the shell, this inline echo, and this SSH thing, that is the that's our private key that works locally.
Public key.
That's a public key.
Yeah.
Okay.
That's a public key. So it allows me to SSH in.
Okay. And so we're this isn't a secret that we're this isn't a secret that we're sharing.
Yeah, this is public. No posting your private keys on Twitch. That would be very, very bad.
Although the likelihood of somebody breaking into your personal laptop and then needing to get to the step where they're worried about having your private key for your fake project here is kind of silly.
I mean, that's true.
But
that's true. We do have multiple layers of misdirection here. So even if you got the key, you couldn't do much with it. But still, public keys are okay. Send them to the world. Private keys, keep them private.
Okay, and also it's just a good idea to be in that habit as well, because or how to describe this. Um, Good security practices, if you're just constantly doing them and always just doing them, even if it seems absurd, then when it matters, you'll be doing it right, right? So, okay, that makes sense. I think, yeah, how you do anything is how you do everything. So, just always practice it that way. Cool. All right, so we got that, and it looks like when you SSH'd into Vagrant,
Yep. So here it is.
This looks good.
Here's that IP address that I specified.
Uh-huh.
It's telling me I can upgrade, but I'm not going to upgrade right at the moment.
Right.
And this is just a computer. I mean, it's just a regular old server. It's all
So
the bells and
now,
whistles.
so now the terminal is actually inside of a. It's not a fake operating system. It's an actual operating system. It's just living inside of your other operating system, right?
Exactly.
Okay.
Exactly. And it's virtualization is its own really fascinating topic. I'm sure lots of people have heard of Docker, and Docker's kind of the new hot thing right
Oh
now.
yeah.
The idea of how does Docker do it versus how does VirtualBox do it versus how do other systems do it, very, very interesting.
Yeah, yeah, yeah. That's definitely a DevOpsy kind of thing to talk about. But we're not going to be discussing so much that. We're going to go right into Ansible, which is now we've created this little container, this little sandbox system inside of our own system that is isolated from the rest of the system, so it won't get muddied by what is already on your computer.
Exactly.
So great.
All right. So first, let me go through all these files because each of them just kind of do a small thing. So this first one over here is your configuration file. And to start off, I just have some defaults, and I have this bare bones configuration, right? Say
Inventory
inventory,
equals hosts.
right? For now, I would recommend don't worry too much about what's in this configuration file. It's just best to know like it works. This
Okay.
this will get us started. But in the future, if you start using Ansible, you can put configuration in here. Like how do you want Ansible to interact with the systems when they run these plays, right? So you'll hear me use the term plays. Ansible uses the term playbook, for the list of steps that it uses to set up a server.
Okay, so Ansible, which is a science fiction term, which means to communicate at a distance.
I did not know that
Yeah.
actually.
In fact, yeah, it's a science fiction bit of magical science fiction technology. The Ansible allows for people to communicate faster than light to each other,
Oh,
instantaneously, which breaks Einstein's laws of relativity. So it's imaginary, at least so far. I'd like to see somebody actually build an actual Ansible. But so far we haven't needed that. The speed of light works pretty well as long as we're confined to our own planet. But it is interesting that they use the term Ansible to mean it's instantaneously everywhere as opposed to propagating out.
yeah,
So,
that actually is pretty cool. I like that.
yeah. But Ansible has another set of terminology for it internally.
Yes.
And it seems like sports. Um,
Yeah, the people who wrote it seem to have kind of an interest in sports, so they use terms like roles and playbooks and stuff like
yeah,
that.
so, you have a role on the team and you have a playbook and there are plays that you're going to make, much like in sports. So this is a weird sci-fi sports combo thing going on here with our terminology. But okay, great. So we've got a playbook, and it has plays, and those plays, when you play them, will do a thing across all the different things that you're propagating this out to, right?
Yeah, exactly. In fact, let's crack open the playbook.
Cool.
So for this example, we're just doing one playbook, but I mean, you can have as many as you want. It's so one thing to keep in mind is you'll notice this is all code, right? So you can see here, this is a Git repo, right? I can do Git status, I can do Git log. So I can save my configuration in GitHub just the same way that I would save my code in GitHub.
Right.
So I
So
can
this
iteratively build it.
right. So this is ops as code,
Yeah,
which
exactly.
normally, like in the before times, before this, you would have people who were sysadmins who would type out what things were, and there are other people who developed the software that they were installing on things. And this way, the installation process is another piece of code.
Exactly.
And you're working with that, which means that it's consistent always. It does the same thing all the time. You don't get those headaches of, wait, did I install this already or not? On this one? How about that one over there? How about number 22347 or whatever? So this makes deploying much more reliable,
Hmm.
right? Cool. Okay. So we've got our first playbook is the name. Gather
Yep, and this is just a YAML file, YAML format.
YAML, so playbook.yml, and we're saying YAML when we say .yml.
Yep.
YML, ML probably stands for markup language, and Y stands for
YAML ain't markup language.
YAML ain't markup language.
I think it's a recursive acronym.
Great. All right, so great. So that's YAML, and this is it's just a way of writing. Ultimately, this is just a text file, right?
Yeah,
So
exactly. It's just a text file.
cool.
So in fact, let's go through it line by line to make sure we understand what each point does. So
Okay.
name is literally what do you want to call the playbook,
Okay.
right? So
That's our choice. Whatever we want to name it.
our now gather facts. Right now, I would say that don't worry about this one too much. You'll see me set it to true in a little bit. But what gather facts does, and to be completely honest with you, I don't fully know what gather facts does, but it's a pre-processing step that basically gets some system information and says, okay, I have the pieces I need to execute certain steps of this playbook.
It sort of makes sure that the operating system is the way that it's expecting it to be, and that everything is ready to go.
Yeah, yeah.
Okay, cool.
Yeah.
Then we got hosts that says vagrant.
Yep, host vagrant. Now let's actually take a look at that. So if you remember, we have our vagrant box over here on the side.
Right.
So I have this little host file here,
Okay.
and you'll notice
And
I have this group
you
at the
just
top.
named it vagrant, and what it actually is vagrant underscore one, and then a bunch of stuff. And
Yeah.
that is
So oh, sorry. So over here we named it vagrant, which is the group of hosts that we want to provision.
and then we have
So
a hosts file that just has vagrant in square braces, and then inside of that is some stuff that Ansible knows what that means. It knows that there's such thing as vagrant1. There is an Ansible underscore host, and then that's set to the actual IP address that actually is our vagrant. And Ansible user equals vagrant as well. That's going to be how the system named, what the system thinks of itself as, right? Is that
exactly.
Sure.
Exactly.
Okay. Cool. All right.
Yeah. And so the important thing to note is this right here is a name that I chose for it, this vagrant one.
So if I wanted to, we could name that anything we liked. We could name it Sally. Okay.
Sally the Ansible box.
Okay. Sally the Ansible box.
And if we
Now we can be we can be cute about those names if we like by naming it Sally or whatever. We can also be like, if we've got a whole lot of those, then it's a good idea for us to name them things that make it easy for other people to look at it.
exactly.
Yeah.
That's exactly right.
Yeah.
So you'll notice the last thing here is the tasks, which is literally the list of things that I want to happen as I set up this box. So just to make sure that this is working and that we haven't messed up the infrastructure here, I just have debug. Just print a message to the screen. Ansible's working. Hello world, because that's apparently what we have to write when we do something for the first time.
Right.
And I have woo.
Now we don't actually have to. It's just that it's tradition, right?
It's tradition. That's right.
Yeah. Okay.
So when we run Ansible playbook and I just pass in the name of the playbook, you'll notice that it says, all right, here's our play. There's the name of the playbook.
Our
that
first
we did.
playbook. Task. Display a cool message. And then it says, hey, Sally. And Sally says, message, Ansible is working. Hello, world. Woo. Okay.
And then at the end, it'll give you like a nice little recap. How many things were okay? How many things changed? Failures?
So that means that nothing changed. Did you previously install this one?
No, actually, I'll ask you. What did we do to our server here?
Nothing. We just displayed a message.
We just displayed a message.
Okay. So if we wanted to actually do something that allows changed equals 1, what would that be?
So let me actually. I'm gonna grab my next commit. I'm gonna cheat just a little bit because a lot of these Ansible commands I don't have stored in my short-term memory, so I'm going to
look it up.
look it up.
Oh, but you actually, there it is. Did you just go back? So you went back through your Git history and pulled up where you were before, right?
I did.
All right. Cool.
So originally we were here, and now I just kind of jumped us over to here.
Okay, so that's a nice. It's a nice thing about Git too, is that you can do stuff like that. If you can move back and forth through any time that you've. How to describe this? I would say that using Git is a little bit like being a Time Lord inside of your code. You can go to any point in history that you would care to go, but you have to decide what those points in history are. You have to leave them behind you in order to go back and forth through them, right?
I'm going to be honest. I dabble in Star Trek, but I've never actually seen an episode of Doctor Who.
Well, I would like to point out that just because we're software engineers doesn't mean that we have to be into science fiction. It's just that it frequently happens.
This is true.
Yeah. But yeah, okay, cool. So we've moved forward in time to where you've already written this, where you have named create a file.
Exactly. Right. So why don't I run it, and then we'll see what happens.
Okay.
Oh, cool. Actually, this is good. This is a problem.
This is a failure. This is an unreachable.
This is a failure. Right.
Identification has changed. Man, this looks angry.
Yeah, it does look angry. So whenever you see this is an SSH key thing. So what's happening is it doesn't recognize this particular known host. So I'm going to rm, let's see, .ssh. If I do that, let's see if that does it.
So you just deleted what the known host was already, and now it's working. And now here it is changed. OK is 2, which means that you named display a cool message that created an OK, and then create a file did another OK, but that one actually changed something, so it also put in a little changed box.
Yeah, so would it help if I just kind of paused and explained like a couple of these steps, or shall I press on an SSH onto the box?
Is there a myfile.txt now sitting inside of this this code inside of our Vagrant box?
If the demo gods are kind to me, then yes.
Where is it? Now you have state and you said touch. I know that touch is a command that you can do in the terminal that creates a file that's completely empty. Or if it already exists, it just does nothing.
That's right. So let's run this again. Let's see what happened. I have a feeling that because I didn't accept the key. That is interesting. Why is that not showing up? I'm surprised that that's not showing up, to be honest. What? So we've got our Vagrant box. Ansible user Vagrant. I don't think it makes a difference that this is named Sally instead of Vagrant1, but we can.
Let's put it back to where we know it was working.
Let's put it there.
Okay.
All right. And actually, you know what I'll do? I'll even go one better. I'll Do a
You're
vagrant
gonna
display.
you're just going to murder the entire box and
I'm
create a
gonna I'm gonna
brand new
murder the
one.
box and create a brand new one, and let's see if it works.
This is one of the
Vagrant
great
hook.
things. This is one of the reasons why software is oftentimes better than hardware, because you can't do that in hardware. I mean, I could pick up the computer and throw it out the window, but then I have to order a bunch of parts and wait for them to come in and put it back together. Whereas with this, you just destroy it and then recreate it.
So this should be relatively quick because we don't have to download like Ubuntu or anything. All we need to do is just set up the box again.
Huh.
So I'm gonna vagrant SSH. It'll ask me for that. So great. Exit. And now let's try running this playbook again and see if it works.
Yeah, it did.
All right.
And that means that we can find that file, right?
Hopefully, unless there's a setting that well, for some reason it's not showing up here, and I'm not sure why.
What if we, instead of touching it, we add a message into it? We write something to it as well.
Let's try it. Actually, and before I do, let me just do my sanity check. So first of all, we're in vagrant SSH, print working directory, home vagrant. I can touch file.txt. Yep, that works.
Okay.
Cool. All right, so let's take a look. So all I've got up here is the documentation for the playbook. For Ansible file. And let's see. So we can change a file. All right, we have state. So let's check out state.
All right.
All right, so we don't want absent. We don't want directory. File without.
If there's a file without any other options, this works mostly as a stat,
We'll
and will
return.
the current state of path. An empty file will be created in the path. If the path does not exist, okay. While an existing file or directory will receive updated file access and modification times.
Okay.
So it looks like it does what we expect it to do. It's just not doing it.
Yeah, and I do not know why that is. I'm gonna try a couple of things and
Okay.
see if they work.
What would you like to try first?
Well, the first thing that I would probably do is play around with this a little bit. I'd probably just rename that.
It doesn't need to be .txt though, right?
It does not need to be .txt. In fact, it can literally just be foo, and it won't have anything there. So there's our, and it's saying that it changed vagrant 1.
Okay.
Then
And we need to SSH back into the vagrant box because we were outside of the vagrant box when we ran that script, right? And there's a file .txt, but there's no foo.
There's no foo. There should be a foo though, and I'm not sure why. So actually, let me try something.
Oh, we are doing the message though, right?
Let me try gathering.
All right, we'll try gathering facts. So let's see what that magic does.
So gather facts, this is kind of the precursor step.
Okay, it's claiming that that happened and that things are fine. Still saying the same thing. Gonna SSH back into our vagrant box. Are we is when we SSH into vagrant, is that actually SSHing into the box that we're actually changing?
Yes. Yes, it should be.
It's not creating some other box.
We should be able to even do that.
Machine with
Oh,
name vagrant is not filed or
what did
configured.
I what did I call this?
Hmm.
Vagrant one. What did I call this?
Is it in the
Network.
playbook? I thought it was in the. Oh wait, in the hosts, right? Vagrant one.
Well, there's Vagrant one, but I wonder if I can SSH in like this. SSH Vagrant at 172 dot.
172. You got 182 there.
Oh, thank you.
This is what pair programming is good for.
Perfect.
Okay.
There it is. You are correct. There's my foo.
Okay.
I was SSHing into the wrong box. Now that is fascinating. Where was I
I
going?
don't know, but it wasn't. It. Yeah, that's the reason because you delivered a package to a certain address, and then you went into the wrong house and were surprised to discover that the package wasn't there.
Yeah, yeah. Okay, let me take a step back. So vagrant SSH
Mhm.
is basically this shorthand command that says if you basically have one virtual machine
Right.
and you've defined it in this vagrant file, we're not going to make you type out the IP address. We're just going to send you right into it.
But there were two of them because we named one Sally.
I wonder if our renaming stuff did something weird, because I we named it Sally, and then a couple days ago when I was preparing for this talk, I was spinning up multiple Vagrant instances to do tests there too. So I wonder if something is cached on my computer, and that is kind of screwing up my history right now.
Well, it's really cool that we figured it out, though.
Yeah, that's actually pretty neat. I like that. But here's a really cool example of why Vagrant, or sorry, why something like Ansible is so important when you're managing thousands of machines. So at this point, we're feeling good about ourselves. We're gonna exit out of it. We're gonna continue on and do our thing. But check this out right here. I created this random myfile.txt. So if I were to spin up another server right now and run this and go in and do stuff, the configuration on the first server, this one right here, is different than the one we're going to spin
Yeah,
up.
they're not totally clones of each other.
Exactly. And so that's why it's so important to do everything through something like Ansible or Chef or Puppet or whatever you want.
Right. Chef and
Cool.
Puppet being other things that are kind of like Ansible, right?
Exactly. Exactly. All right. Good job, everybody. That was
Whew.
cool.
Yeah. So, all
All right.
right. We're surprisingly enough, this is a really good stopping place. So,
Oh, nice.
um,
Nice.
yeah. I guess the first thing is like, what did we learn today? We figured out that you can create other operating systems in your operating system and have them run, and that anything that can exist as hardware can also exist purely as software. Okay. Let me see what else I can think of that I learned. That Ansible is a tool that allows you to put the exact same files or the same, you make sure that every single computer that you're touching is going to be the same and uniform across a whole system, right? And then what else? Oh, yeah, the command vagrant SSH is actually syntactic sugar on top of another thing where you SSH vagrant at and then put the IP address. And so, and also we learned how to go through and puzzle through having something unexpected happening and not banging your head against a wall and being like, it doesn't work. Um,
Yeah.
yeah.
Today I learned that the when you run Vagrant, if you're not careful, it'll actually cache a lot of the multiple machines you create, and sometimes you'll get routed to the wrong machine. So,
'Cause Ansible was fine. We were going
and,
to the wrong address.
yeah, exactly. As
Yeah.
as always, Ansible's just fine. Problem was with us.
Yep. Yeah, I hear you on that. With software, a lot of times for me, it's a meditation. And I'm learning where my brain has blind spots.
Mhm.
So yeah, it is a job where it is a constant meditation and a challenge to meditation um, to work in software, or for that matter, in doing DevOps, which is basically ops as software, or software as ops. Yeah. Uh, what else? That you don't need a lot of math in order to be a software engineer, but if you like it, then go for it. By the way, I didn't ask. You said you'd never done it for client work. Have you done anything with calculus or any other advanced mathematics when you're programming on your own?
Oh, for fun? Yeah, definitely. I love math. I love physics. I actually have a so one thing I like doing in my free time is I have this little site called Cupcake Physics,
Oh,
and like I basically try and teach physics. And so if you come over here to the blog,
oh, I am
like
so glad I asked that question.
I mean, there you go. Here's some math.
Oh, whoa, that's that. This just looks. This might as well be magical incantations here to me.
It's actually not too bad. So I will admit, the reason I did this is because like when I was in grad school, I found that I was a little bit like slower than everyone else in my class. I've had a lot of difficulty uh, kind of ingesting these physics concepts. And so what I found helped me was like forcing myself to teach people these concepts in excruciating detail.
Right.
Like when you go through a textbook and it says this is left as an exercise to the reader. I hated that. That's the worst thing.
So
So
it seems like, um, yeah, and I gotta say there is something to that. And one of the reasons I like mentoring as well, because every time that I teach something, I learn it myself again and deeper.
mhm.
And so, yeah, there's something really, really special about being able to explain a concept as a way of proving that you know it. And it also teaches yourself again too. Yeah, this is really cool. So do you deploy this yourself, right?
I deploy it myself. In fact, here I'll tell you what, we're on the right computer
Oh wow, this
to
is
show you that I'm not just trying to do Ansible randomly. Look at this. Here's my Ansible config. This is all of my Ansible stuff, right? Here's some
and,
Terraform. Like all of this is done through Ansible. And here's some playbooks. There you go. Here's a playbook.
and that has so this is what you use to deploy that website. That
Yep.
that's so cool. And of course, this is also in GitHub as well, right?
This is in GitHub. Yes.
Cool.
And
Um,
so you can see that you know I'm okay showing this right now, right? Because I'm using things like Ansible Vault to guard secrets. I'm not storing sensitive information in this
right.
repo, stuff like that. But yeah,
That is really cool.
and I mean the way you build something like this up is you write a step, you run it, you try it, and if it works, awesome. Write the next one, and if not, do some debugging.
Yeah, don't try and keep moving on just even though something isn't working. Fix it first.
Mhm.
Make sure it's really nice. Make sure it's
Yep,
solid and that it's well named and everything, and then move on.
exactly.
Yeah, yeah, yeah. Get that totally. Cool. So I've got two questions to ask you, Cyrus. But before I
Okay.
do, I have to thank a few people that are on the stream that have helped make this show possible. My production liaison is Matt Pittner, and he has a show called Crockpot Cinema that's on Outpost 13 on Sundays, where it's a cooking show and they watch a movie. And the cooking is always themed for the movie. My designer is Aaron Harvey. He created the graphic that you see down there. And that graphic is, and he has a show also on Outpost 13 called Infinite Trek, which is a podcast about Star Trek. Then marketer is Lucas Vanosic. He has a show called Two Liars. It's on tomorrow. Should be on tomorrow, depending on whether or not they have another show this week. But it's a talk show or a game show, and it's 2 teams of 3. And they're going to make a statement, and each person on the team is going to claim that statement as theirs. One of them is telling the truth. The other 2 are lying. And the other team has to figure out who's telling the truth and who's lying. Then our bot master is Cody Bushy, who has a show called An Actor Unprepared. And that is on Mondays. And he gets an actor, a director, and a writer together, and they put something together right there on the stream. The music that you heard before and after the show is by Alex Kahn and Arlo Sanders. They have a show that they've had on the stream called Made Up Music, which is coming back during our 13-hour marathon, which is coming soon. Otherwise you can find them on Spotify, actually. So just look for Made Up Music on Spotify, and you'll see all the songs that they made up right here on the stream. Thanks for that. Cyrus, 2 questions for you.
Okay.
The first one. What do you think the most important thing to remember about? Let's do what's the most important thing to know about DevOps?
What's the most important thing to know about DevOps? Okay, so I can answer that on maybe a personal level. So a lot of times when you try and sell I need to be very careful. When I personally have tried to sell DevOps to people in the past, a lot of people think like, oh, this is a lot of work. Why should I be doing this? Like, why is it important to implement all of this overhead? And I think it's important to know where we came from, because that dictates why DevOps is so important, right? Remember back in the day, you had these 2 conflicting groups. So you literally had groups of developers with opposing goals.
They were they were at odds, like Gryffindor and Slytherin.
Right, and so you can't effectively work on a team. I mean, imagine if you develop this awesome feature and you go to your ops team and you say, "Okay, deploy it," and they're like, "Fine, whatever." Like,
yeah, that sucks.
Imagine working in that environment. And so basically this idea of, all right, we'll help you a little bit, kind of meet you halfway, you help us a little bit, and we'll meet in the middle and things are good. And overall data and research has shown that like teams that adopt these practices tend to deliver safer, consistent, stable software.
Right, because of course there are less ways in which you can make a mistake. Mm-hmm. And if you do make a mistake, it'll make it everywhere.
Yeah.
Right. Cool. Okay. And if somebody wanted to learn more and learn how to start deploying their own software, where would you have them start?
Heroku. I would have them start with something like a platform as a service. Right?
Platform as a service called Heroku. So if you Heroku.
Yeah, let me actually pull it up, and I'll say I'm in no way affiliated with Heroku or whatever.
Right.
But I use Heroku because it's just so darn easy. Like especially if you're building like PHP, Java, Rails, stuff like that. You type in a few commands to set up Heroku on your command line. Git push Heroku main, and you're up and running. Your site is deployed to Heroku.
Do they have like tutorials that like you could just start up an app randomly and just a really basic like Hello World app and just have it actually deployed to the actual internet?
Oh yeah. In fact, I just clicked on their documentation. I'm going to use Ruby because I use Ruby.
Sure.
about getting started with Heroku on Ruby, and I'm ready to start. And they're free for the
Cool.
lowest tier free account. They're free. So if you type these in,
That might be a
Heroku
really
login.
interesting way into just learning about software also, is just starting off with like the most important thing is that you can deploy something. Now you've
Yeah,
deployed something, let's change it a little bit and deploy it again. Now with our new added thing,
yeah.
and wow, yeah, that's a cool way of starting to learn about software. Actually,
Hmm.
usually I start off with like a bunch of exercises or something like that online rather than starting off with like the thing that matters, which is can you get a thing that's useful to other people? You
Yeah.
know,
I think the koans and the exercises are really useful when you are learning the language itself,
right?
right? But once you know Ruby and Rails, I would say the most useful thing you can do is build a walking skeleton, which is this idea of like one full vertical slice. I
Huh.
have an app, I go to this page, I click the button, and it says, "Hello, welcome to the app." And you've
Right.
connected the front end, the back end, the database if it exists, like all those things together.
Oh yeah. Earthbase 2 says hello world. Can you hear me now?
I can hear you, but you're very soft.
I'm very soft.
Oh,
Oh,
now you're good.
okay.
Now you're good.
It took a second for it to get back up. Um, Great. Thank you for catching that.
No
um,
problem.
Yeah. Earthbase Two said hello. It's a hello world basically. Hey, Earthbase
Mhm.
Two. Thanks for tuning in. And yeah,
Yeah.
cool.
And when you do this in Heroku, you're not going to be using Ansible, you're not going to be using Terraform because most of this infrastructure stuff is handled for you, right?
Okay.
And so as you become more confident with Heroku, what you're going to find is like, oh, I really wish I could put a load balancer in front of my app because I'm getting more traffic, or, I want to do this with my app. And you're going to find that Heroku might not have the flexibility you need, and that's fine, right? It's not meant to
Right.
have all the flexibility you want. And at that point, you can start diving into AWS or DigitalOcean or Google Cloud or whatever it is you want to do. And then you'll start pulling tools like Ansible and Terraform and all.
Cool. That's great. Yeah. Cool. So you could actually start with this and then start learning the language after you have deployed something, so
Mhm.
that you can change the code in various ways.
You could literally do the Rails init or Rails new, generate just a blank Rails app, and then deploy it to Heroku. That's all you need.
Ah, wow. And then you could turn that into a blog or into a video set or whatever you like. Probably best to start with something simple like a blog, um, and start talking about your journey in software and use your own um, deployment effort as also the place where you talk about how you deployed.
Hmm. Hmm.
Cool. Okay. That's great. Cyrus, thank you so much for coming on the show. We're going to head off the air now, but in traditional software development, we're going to have an awkward goodbye. Now I'm just going to look and see if I can find the close button and transition from that. Oh, look, there's another me on there. Okay. I guess you stopped sharing your screen then. All right.
Oh, oh,
Cool. Um, so I think it's closed now. Okay.
I can still see you.
Oh, you can. No, wait. I
Yeah.
don't think anyone else can. Oh, wait. Hold on. Our mics are still hot. I think I just turned off all the sound. Oh, wait. There it is. Oh, yeah. There it is. All right. Cool. Good.
a man. If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret. Cause I'm gonna take you down where the beats are pumping. Down to hell where the lava's jumping. In the mountain, lava's jumping. Down to hell where the lava's jumping.
Let yourself fall, cause you only get higher. Let yourself drop like a bee on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
I walk this life. The only steps I can. Steps too high. I'm just a man. I walk this life. The only steps I can. Steps too high. I'm just a man. When you start saying a mountain is a mountain, a river is a river. But when in Zen, a mountain is not a mountain.